the least possible disk rating and all that kind of stuff. It's like this.
Well, so if you end up doing I3s, and you can go ahead and get instance types that are large enough to where you'll have more than enough space. Like I guess like just depending on the instance type. If you're doing EVS volumes, then you're maxing it out at 3.4 terabytes of volume. So if you want to go any further than that, just do a RAID 0 on that. Oh yeah, and never do like RAID 5s or 7s or anything. Yeah, like those are pretty bad for Cassandra. If you have the extra money to spend, then you could do a RAID 10 or a RAID like 0.1, so that way you could lose one drive and still keep going. But most times, like everything that I'm covering right now is how to swap out nodes. So worst case, if you're on RAID 0, you have one disk failure, just kill it and just swap out node.
Okay, is there a best way to deploy that so that it does RAID more seamlessly than, can you can't ship a Docker container so that it does the RAID for you, right?
Oh no, yeah, no, that has to be done through something like Chef or Ansible.
Right. Yeah.
There's a script online. It should still be under Ricano/combo AMI, and in there's like DS2 configure, and you search for RAID. Like I'll run through all the steps, and that's just like all best practices that I've kind of picked up, and like that's the way that we do RAID, or that's the way that I typically recommend RAID.
Yeah, that's what I use to
Oh,
stripped out all the rest of the stuff.
Yeah, nice. Cool. Yeah, the code definitely wasn't the best, but hopefully it like you were able to strip it out, so that's good.
Do you run into it? So one of the issues of, and maybe I'm trying to remember what instance I actually deployed it on, but that basically the root partition is very small.
Mm-hmm.
So like you gotta add a different package to it, or maybe an update or whatever, the root partition can run out of space. So that or it's even just like installing the DSE package by itself, the root partition runs out of space unless you kind of symlink some of those folders that you probably shouldn't symlink to your new rated partition.
So there's this this block thing. Okay, so whenever you're if you're using AWS tools or EC2 tools or whatever to go ahead and launch an instance, you can go ahead and tell it, hey, I want this particular configuration, and you can ask for more than the 10 gigabytes by default. Because it should come with 10 gigabytes by default. I've never seen anything with smaller than 10 gigabytes by default.
Yeah, well, this is for the ephemeral. So it's not EVS backed.
Oh, okay. So how much is it on ephemeral? Like just like 1 gig or something?
Yeah, it's like 1.9 or 2 gigs or something like that. It's like super small.
Oh man, okay, cool. Yeah, yeah.
I thought that was like M4, but maybe I'm. So when you do M4, you do it on what kind of disk?
EVS.
You do it, so M4. Oh, because it backs up backwards.
Yes. So let me show you that configuration.
Oh yeah. So I was doing M1 larges. Yeah.
Okay. Yeah. So what I've been doing whenever I launch instances. Okay, so you run instance, and then you give it a block device mappings, and then with that, I'm able to go through and say, hey, for my root volume, I want 300 gigs. But you're right, this is only for EVS. Yeah, so I'd assume that there would be that exact same sort of thing happening for the other, or for ephemeral storage, you might have something similar, and it's just an option to go and say, hey, like I want to overwrite possible, but.
Yeah, that's interesting. If I can get that, I didn't realize this was like M4. I was just like anything EBS was just like the network latency, so I didn't realize M4 I guess was closer to it.
Yeah, like it was. So I think at the Cassandra Summit, like maybe 2 or 3 years ago, that's when people started saying, hey, like I'm doing stuff on EBS and it's totally fine. And then slowly, like you had one person doing it, and then like definitely by last year, everyone kind of accepted the fact that EBS is now okay.
Cool, awesome.
And then Nate, our CTO, was able to have a conversation with some people from AWS, and he kept like pushing them, and then he finally said, no, like they're actually like right on that EBS backlane. But other than that, like we haven't found any documentation for that. It's just like a person-to-person conversation, and Nate just kept saying, hey, like tell me, and it's like this is what he said. And I was like, okay, cool. So.
Does anyone talk about that 125 megabit per second throughput limitation we have? Because we run into that more often than the IOPS that we run into with the EBS volumes. So, for example, you put any of the M3 or M4 instances, M4 instance types gets you only up to 125 megabits per second, especially if you're running a Spark load on top of Cassandra, it just chews up that 125 pretty quick. And then you saturate on that 125 forever until, meaning even though you have IOPS, you're doing it at probably 3000 or something, you never hit the 10,000 IOPS that you get with 3.4, right? 3.4 terabytes you never hit the 10,000 IOPS limit, but you hit your throughput limit much faster. So that was one case wherein we went with EBS supplement and then we had to come back to it.
Okay,
So
cool.
just be aware that depending on your workload, if it's like online transaction, it's fine. Meaning transactions, OLTPs are coming back and forth, you just needed more IOPS, it's great, but when you hit that 125 megabits, you're just stuck with that throughput forever. So.
Oh, nice. Okay, cool. Thanks.
So that's the network load or?
No, that is AWS documentation for that instance type. So they give a maximum throughput of 125 Mbps
That's
per
data,
second.
that's the amount of data, volume of data,
The
right?
volume of data that AWS gives you for that particular instance type, so you cannot go beyond 125. So we've seen like more often IOPS is not a problem, but throughput per second is just saturated at 125. We start seeing slowdowns.
Oh, that's a gigabit, so that's 1 gigabit per second. Maybe that's why they recommend half the 3.4 is the max, but half that is optimal or something like that.
No, even with 1 terabyte, you'll get 3000 IOPS.
Yeah.
Unlimited 3000.
No bursts, you
No
just
bursts,
get
no.
3,000.
Yeah.
But it's just not about the IOPS, it's about the throughput that is
Right,
giving it.
right, yeah.
Yeah, and then everything I've seen is mainly just compaction of files, and then also when you end up getting super large partitions, like if you are already prone to large partitions, and if you have more than 2 terabytes on disk, then your partitions will be larger, and that's going to have a higher memory load. And there was something as well with LCS. If you're running LCS with more than 2 terabytes, then LCS just pretty much never ever stops, and then it ends up like just crushing your machine if you leave it over like 4 months or something like that. So if like the general rule of thumb is under 2 gigs or under 2 terabytes is a lot better, but if you could run at like 200 to 500 gigs is what we used to recommend. Like that was the old standard. So push it higher than that, but not too high.
Cool.
Want to start? Yeah, I'm done.
Cool. Hey guys, I know most people here, but good to see at least one new face. I'm Nick. Guys sending you emails. Sorry about all the confusion on location. You guys got a couple emails about that from me. What I've heard now is that this will be our home for the foreseeable future, so hopefully just keep coming back here, but if they change that, I'll let everyone know. We don't have a July meetup scheduled, so if anybody would like to talk, please come tell me. If anybody wants to see anything specific, also come tell me, and we'll see if we can make that happen. And similarly for August, we don't have anything scheduled, and also Capital Factory is sponsoring or hosting a Women's Month in August, and we'd love to be a part of that. They're asking meetups to participate if they can, so we would love to have a woman speaker. As you can see, that's probably a worthwhile goal based on just the diversity of the crowd here. So if anybody knows anybody that would like to give a talk on Cassandra or anything related to Cassandra, really, honestly, we do talks on Spark and talks on Graph and all that stuff. Definitely let me know. Send me an email or shoot me their contact info. That would be great. Yeah. Beyond that, we're going to hear from Joaquin, who's been an awesome member of the Cassandra community for probably going on 6 years now. So he knows his stuff, and I'll let him take it away.
Hi. Yeah. So my name is Joaquin Casares. I typically stutter, especially on my name, as you just saw. The presentation today is called "Joining a P2P Conversation." So a little bit about myself. I'm currently a consultant at The Last Pickle. Can you all see that okay, or is that too small in the back? Yeah, sorry. I don't know the best way to increase that. There aren't a lot of slides that are this small. Worst case, I will be able to shoot this deck out to you. But if y'all want to move closer, yeah, sorry about that. Previously, I've been at The Last Pickle for about the last 9 months. Before that, I was at Umbel doing kind of a data access layer between Python and Django that interacted with Cassandra, MySQL, Postgres, and a little bit Dynamo. And then I went in and started at Rapano and DataStax. Actually sat next to Nick. Nick taught me how to use Node tool, so that was very useful. I was a support engineer for about 2 years. Ended up owning all of our customers for about 9 months out of those 2 years. At the end of that, I think we had 200 plus customers. Was software engineer and test, so I did a lot of testing with AWS, just launching clusters, making sure they were all provisioned, throwing workloads at it, killing them. Was a demo engineer for about a year after that, and just pretty much started dabbling with Docker and VirtualBox, and just getting demos that our salespeople could say, hey, this is the power of Cassandra. So a little bit about The Last Pickle. Together we have about 50 years of combined experience. We definitely look at ourselves as being a member of your team. So whenever you contact us, on our very first interactions, it's about 1 hour free consultation. Sometimes we could figure out your issue and you change a setting, your latency drops by 75%, you never talk to us again, which is great. Occasionally you'll go through and actually need something else, so we'll deliver a 40-page document, and that document tells you everything that's up with your cluster, things you should look at, things you should change, things you should consider. And then whenever you're ready, you contact us again, and we'll work through the rest of the problems. Where do we go from here? We're going to go ahead and cover peer-to-peer networks, just a basic overview of that, because that's what actually got me into Cassandra. Cassandra fundamentals, just seed nodes and tokens, just so that way, does anyone here not have experience with Cassandra and seed nodes and tokens? Awesome. Okay, cool. So I'll go and give you a little bit of that information so you know where everything else kind of leads to, and then how to add capacity, how to check on the addition of capacity, on things that you shouldn't forget whenever you are doing all these operations, and then how to actually forget the nodes that you actually want to remove. So I'll cover both adding and taking away the nodes. So a little bit on P2P. I was thinking about starting with Napster, but I don't know enough about Napster, so I figured just from Kazaa to BitTorrent. Kazaa was a peer-to-peer network, and we all thought it was great if you ever used it. The way it worked is you ended up having super nodes, and these super nodes talk to peer nodes. So you would contact one super node. The super node would tell you who your peers are whenever you search. It would search across other super nodes. And the super nodes had a different hat on, which would go ahead and communicate across regions, so that way you could get a broader library of files. It turns out that there was actually a centralized part to that, which was Kazaa.com. So when the legal teams came in and said, hey, you actually have to turn everything off, once they killed that Kazaa.com super node, everything else just kind of fell apart. You could still contact a super node if you remembered, but other than that, the peer-to-peer fabric that was there was completely dead. BitTorrent does something different where you end up having trackers, but it's the same sort of thing where you have like this hub spoke sort of thing going on. So you can go ahead and send a hash of a file. A tracker will keep that. If a connection is ever severed to a tracker, either by the network or if something's like blocked or whatever, if there's another tracker that has that same hash, then you could rest assured that that's the same file and it starts pulling that down. So this is where my mind was when I first heard about Cassandra. I was like, whoa, you do databases like this? Like, yeah, that sounds great. So the first piece before we even get into the way networking works with Cassandra are Cassandra tokens. Cassandra tokens are essentially, or in this example, I'm going through letters A through Z, and I'm going through and splitting up the tokens with A through G, M through T, and just like in those sections. If you're ever looking at anything through Node Tool, you'll actually find that the tokens actually work backwards. So for node A, it's actually exclusive to T and inclusive of A. For node G, it's exclusive of A all the way up to G. So if there's just one tool where you can find out, you can feed it a partition key, and it tells you what node it's on, and if you're ever like, that doesn't match up, it's because it's going the opposite direction. So just something to keep in mind. With newer versions of Cassandra, we no longer assign one token per node. Instead, you go and give the node multiple tokens. So in this case, we're using 2 B nodes per node. So you end up having range A through W on node 1 and J through G on node 1. You do see how node 4 does have their ranges back to back, and that does occasionally happen because whenever you're assigning tokens, they're assigning random number of tokens, or sorry, your token assignment is random, so your range assignment is also random. So whenever you add a node, and this is like one of the really great things about V nodes, is when you add a node, it's going to go ahead and choose 2 random tokens, and you're going to get ranges out of that. In this case, you'll see we have a small range of just B and A over here, but in this case, we have a slightly larger range. The way it used to work before is you would have to go through and leave A as is, you'd move G, you'd move N, you'd move T, and then you'd add that 5th node. With V nodes, you just say, hey, I want a new node, it's random, it will get done. TLP typically recommends about 32 to 64 V nodes per instance. And the reason for that is 256 ends up getting 256 token ranges that node is responsible for. So whenever you're doing repairs or bootstraps or any sort of streaming operation, you have to do that streaming operation 256 times. So if we just kind of lower that number down to 32 or 64, you still have the benefit of being able to spread across your new nodes tokens in a very nice manner without having that extra overhead. We also recommend using the same num tokens count per instance. So you don't want to have one node say that, or node A has 100 tokens and node B has only 2 tokens. Then you're kind of lopsided, and when you're doing the math, and this one's taking more load, and just all the way through, just keep it standard, and in the true peer-to-peer fashion, if they're all equal, then they should act equally. So it makes debugging a lot easier. A small tidbit, especially if you've been running Cassandra for a while, Cassandra does, or used to use the MD5 partitioner kind of hash. Now we moved to the Murmur 3 hash. With Murmur 3, you end up getting lower chance of collisions, and you also have a 6x increase occasionally instead of, or over MD5. So that means when you're going through and asking, hey, I want to insert Joaquin's birthday, you have to hash Joaquin, you have to find the node, you have to send it over the network, hit memory, store it on disk. But if that little part's 6 times faster, even when you request any information on Joaquin, that's going to be a real quick hash. So now into the peer-to-peer side. Now that you know that we do have hashing, every node has a hash, now you have ranges, and now we're starting. So whenever a node is joining, let's see, yeah. So whenever a node is joining, the node has to first contact the C nodes just to figure out what the topology looks like, where it's actually going to be, and figure out who's going to be taking it on as part of this data center. Once it finds that data center, it goes through It streams all the data back to that node. And that's that portion that we covered before, where 5 takes on different token ranges, it streams those token ranges over. If there ever is a seed failure, so this is after bootstrapping, if there ever is a seed failure, that node will still be able to contact everybody else. So in a peer-to-peer fashion, we can kill the seed nodes and the network will still stay up. And that's all accomplished through gossip. And gossip is exactly as it sounds, it's just echoes. There is one person that works on gossip on the Cassandra project. Like, he does a patch occasionally, other than that he doesn't touch it, like it works like as it should for the most part. There was a real cool use case that I heard at the software architecture conference last year, where it was some CDN provider, like maybe Cloudflare or somebody, and they're able to detect if a CDN endpoint is down within a fraction of a second using only like 9 kilobyte like round trips or something. Like, it is super cool stuff. So yeah, like gossip works for CDNs across the world, and gossip will definitely work for your Cassandra clusters with a limited number of nodes. So the only time that seed nodes become an issue is when you're trying to add a node to a ring, but the seed nodes aren't available. So the seed node is pretty much that introduction. So it has to say, hey, like, here's your seed list. You contact those seed nodes, and the seed nodes aren't up. There's no way you will ever know who your peers are. The other way to fail a bootstrap process is if that node is acting as a seed. So let's say we had IP address .49 and we used it for Cassandra one time, and then we left it as the seed node and all the other YAMLs. If it's been like 2 weeks, we went ahead and got some new hardware, we swapped out the disk. If we're going to add that back in, we have to update all the other nodes and say, hey, number 49 is no longer a seed node. It's either you do that or you change that IP address. So just something to be aware of, and the good thing about it is it will fail like from the very beginning. As soon as you try bootstrapping, it's going to stop, and you check your logs, there will be an error message that says, hey dude, like, your seed node, you can't do that. So TLP definitely recommends that you use the same seed nodes throughout the cluster. So it's not that it's there's like a master and slaves, it's not hub and spoke, it's just that these seed nodes are going to be contacted a little bit more often, and we're going to have a greater, more up-to-date view of the rest of the cluster's topology, really. We also recommend 3 to 5 seed nodes per data center. And 3 is just like a magic number, and that's just kind of, your replication factors are typically set to 3. So, if you have a replication factor of 3, use 3 seed nodes. That way, if one node ever dies, you still have the ability to have a consistent view of the cluster. Maybe you have a super large cluster, maybe you have 250 nodes per data center, then you want to go ahead and use, maybe 5, maybe a few more, but you definitely don't want to have 10 nodes and use 10 seed nodes. There's no reason for that. So 3 to 5 is that good sweet spot. So now on to the actual adding of nodes. Does anyone have questions so far on the fundamentals that I've covered? Cool. So whenever you're bootstrapping a node, it goes in different phases. The first phase is to announce, and you're going to go through, you're going to contact the seed nodes saying, hey, I'm a new node, this is my IP address, this is the data center I'm going to belong to, this is the rack I'm going to belong to. Put me in the right place and get me in contact with who I need to talk to. Once that's all done, then the nodes that you're now neighbors with within that data center will start streaming data to you. So the other nodes will go ahead and leave some of their token ranges, and they will be giving up those token ranges for this new node, which means they now have less responsibility, and this node is going to pick up that responsibility. What that ends up looking like is like that chart that we saw earlier. And you'll see that for node 3, you end up having token ranges D, C, and B. And you're not going to have A because A is actually owned by 1. For node 2, you end up having ranges Q, P, O, and N. And these are now going to be transferred over to 5. And you're not looking at M because it's exclusive, so M's actually owned by 3, just a tidbit. whenever you're in the process of streaming the data, you will have that data live on two nodes at one time, both the node it was coming from and the node it's now going to. Once that's complete, you do want to run a cleanup process. And what cleanup does is say, hey, these token ranges I'm no longer responsible for, so it's going to go through, it's going to do a single SS table compaction and just scan that table, anything that is no longer responsible for it just chunks, it writes it, just streaming from one file to another file, writes it on disk, this one's going to be smaller, and everything's now on the other node, or only on that other node. So the questions to ask yourself to see if you want to do the bootstrap process, the first thing is all nodes have to be up. There's a way to get around it, but just go through, check your monitoring, and you should hopefully have a monitoring for your up nodes. If not, node tool status will tell you if your node is up and normal, or normal and down, and or up, yeah, down and normal and other things. But you want them all in the up and normal status. The reasons for bootstrapping would be if you're running into disk capacity issues. So we typically recommend more, or at least 50% of free disk space. You know, like a good number to think about is about 25 to 50%, like in that general area. If you're running at 10% free disk space, it's probably time to bootstrap some nodes into your cluster. If you're ever hitting CPU issues. So Cassandra scales linearly as far as disk, memory, and CPU are concerned. So if you're running Spark jobs and you end up seeing that all your CPUs are pretty much maxed out at 100%, if you add twice as many nodes, you will have twice as much CPU to go ahead and scan those token ranges that each of the nodes are now responsible for. Because each of those nodes are going to be only responsible for half as much data, therefore they're going to be doing half as much work, and they will also be responding to half as many network read requests or write requests. If you ever have a business a requirement where your latency is a little bit too high, where you're responding in 200 milliseconds but it should be 20 milliseconds, then you should add 10 times as many nodes. When you add 10 times as many nodes, your latency will decrease by a factor of 10. And also, if you ever run into issues with token hotspots. So in some cases, let's see, so you go back over here. So in some cases like this, where node B only has a very small range, but you end up having node 4, and node 4 has like a larger range. Those are considered token hotspots, and when you do that, that means that your requests are going to hit that hotspot more often, and you'll be able to see that if you run node tool status and your key name or key space name, and you can see the amount it owns. So here we see this one only owns 3.5, and this one over here owns 6.8. So if we ever want to get a little bit load off that 6.8 node, we can go ahead and bootstrap a node. If we join it into the right token ranges, then that node will respond less frequently and have less of a load. So if the prerequisite is met where all nodes are up, and if you wanted to do any of those things, you want to go ahead and bootstrap. It's just the normal way to add nodes in a cluster. It's well tested. Yeah. So the good thing about it is Bootstrap does play it safe by default. So whenever you're adding a node to cluster, it's in the up and joining state, and that means that it's not really part of the ring yet. It's just grabbing that information. They are sending new writes over there. It's preparing to get there. Once it is in the up and normal state, it is now part of the cluster. So if you turn that node off, the rest of the nodes will remember, hey, this guy's responsible for it. We're going to hold hints for it, but that node has to come back. If you don't come back in a certain time period, which I'll cover later, you have to do certain things. But also, if you ever want to restart, on Cassandra 2.2, Node Tool now has Node Tool Bootstrap resume. So if something fails for whatever reason, like maybe you were writing to like the wrong disk partition, you move your files over, move to the next the correct disk partition, like turn it back on, everything's fine. That's where Bootstrap resume would be helpful. For everything else, you would have to clear out all your data directories and try again. If you leave data on those data directories, the node comes up and says, hey, I'm actually part of the cluster. And now it's going to start responding. If you send a request and say, hey, what is John's birthday, I might not have that information because I only streamed in about 10% of the data, so I'll say, hey dude, I don't know. And we never want to do that. So if you're ever retrying Bootstrap, just clear out all of your data directories. One thing to just make note of is you do want to clear out your commit log directories as well. And sometimes people will forget and think, oh, I just need data. But the thing is, if it starts up, if there's data in the commit log, it says, I'm alive. And you never want it to think it's alive. You always want it to think, hey, I'm completely fresh. I want to talk to C nodes. I want to know what my tokens are. The good thing about that is you can do popcorn joining is what we're calling it, or like roll the dice joining. Yeah, it's not great. Like you can go through and you can define your initial tokens, but most times like random is good enough. But if you are ever in a situation where you really want to get rid of this 6.8% ownership and you want to split that up a little bit, you can go ahead and start it up, try the Bootstrap process, look at net stats, and it says, hey, I'm moving 600 gigs from that, and if that's not enough for you, turn it off, clear everything out, wait 2 minutes so Gossip forgets that there was even a node there. Once that happens, wait an extra 3 just to make sure that Gossip stops echoing, and try it again. When you do node till net stats, this time it says, hey, I'm actually streaming 1 terabyte from that node. If you're happy with that, you just let that Bootstrap continue. A few don'ts. So we already covered that seed nodes can't be bootstrapped. There's also an auto bootstrap parameter sometimes that's left behind in Chef, just because that used to be a parameter like in early like 2.1 or something like that. Typically, I just recommend just taking that off. Some people leave it as false, and whenever they're doing operations, they might forget, and then we run into issues. So just take it off. It defaults to true. You're fine. If you ever have data on disk, it's going to default to false. Don't join more than 1 node at a time, really. If you desperately need to join more than 1 node at a time, just do it 1 node per rack. That's a little bit safer. If you ever need to do more than 1 node at a time in the same rack, at least wait for 2 minutes. If you ever need to do it when a node's down, you will also need to go ahead and include this consistent range movement equals to false. I believe you need this as well for if you're doing 2 nodes at the same time now. And what this is going to do, right? Yeah. Yes. So you definitely need this for both of these parts. If you're going to do that, it will override the default guarantees where we're just saying, hey, it's completely safe, do bootstraps, you have no problem, consistency's fine. You're saying, hey, I know what I'm doing, I have a little bit more of advanced knowledge, but that trade-off is that might not have all the data that you need because token ranges are moving at the time. So once Bootstrap's complete, you will want to do a rolling repair to make sure your consistency is fine across all nodes. Also, I get questions occasionally where it's like, hey, I want to go ahead, or I was running M2 instances, I want to run, I was running Cassandra 2.2 and I want to run Cassandra 3.0 now. Can I go ahead and bootstrap Cassandra 3.0 into my 2.2 cluster? And the answer is no. Mixed clusters are never supported in Cassandra because it does break streaming, but also it's not supported for longer than the time it takes to move from a rolling upgrade from 2.1 to 2.2. So yeah, so it's recommended if you're going to be doing a rolling upgrade, go ahead and start, first thing in the morning, you do your upgrade all day. By the time you're off work, hopefully everything's done. There's no more mixed version nodes in the cluster. And that means your streaming operations work again. So you end up having your repair processes work and anything else that's needed for Cassandra to really do its thing. And don't forget about racks. I'll cover that later, but it's just one of those things that you should always kind of remember. So yeah, just one slide on cleanup, which I kind of covered. It's pretty much a single SSable compaction. You don't really need to run it. So if you have 50% free disk space, don't worry about it. Whenever a next compaction happens, if that key shouldn't be on the node, it will get chunked. If you're ever at 10% capacity and you needed to add a node because you wanted capacity or disk capacity to be lower, then as soon as that bootstrap is done, go ahead and run the cleanup and you will be able to free up that disk space. And again, just keep free disk space under 50%, somewhere above 25% is ideal. Yeah, so this is the second way out of 3 to add nodes in the cluster. Does anyone have a question so far on Bootstrap?
So while you're streaming, after you've bootstrapped your node in, at what point is a node usable?
Okay,
Does it have to, the new node, does it have to finish completely or?
yes.
Will it be- Okay.
Yes, so pretty much when it's in the up, so if you run no tool status, you'll see it in the up and joining state. Once it moves from up and joining or UJ to up and normal or UN, then that means it's now servicing read requests and write requests.
Okay.
In all other cases, it will be getting write requests sent to it, but since it's still in that finicky state, it's joining, I really don't trust you yet, it'll get those writes, but it's never gonna be used as part of, if you're doing a write of ORM, that's not gonna be one of the two of the 3 nodes that you're asking for.
Is there any way to improve the bootstrapping process?
Improve it like as far as speed.
Yeah. For example, like last week when I bootstrapped a new node, it took me like 45 minutes, and today it took 2 hours. Like the number of nodes in the cluster goes up. Bootstrapping the new node it's taking a lot of time here. So how can we reduce that?
If you use if you change the number of vnodes from 256 to 32 or 64, that should help. You can also go ahead and change.
All clusters in all the servers in my cluster have same capacity, so I should go with the 256, right? I don't want to change it to 32 or 64.
Yeah, so if they're all at 256 already, then you will want to add a new data center, and that new data center will have 32 or 64 vnodes.
Not new data center, just like new node to the existing data center.
Yeah, so in order to improve your bootstrap times, you want 32 or 64 vnodes.
So what is the mechanics behind 32 or 64?
So you want enough randomness to go ahead and have, so you want enough randomness to have 32 choices to go ahead and break up your partition ranges. The randomness that 256 delivers, it's super high randomness, but you're also having to bootstrap 256 token ranges. If you're able to bootstrap fewer ranges, that helps streaming a little bit. It also makes it a little bit more reliable sometimes. But you can't change.
It's just that.
Huh?
On the contrary, it's just that when we have replica of 3, for example, and the node losses, it's just that I have with 256 more randomness to lose all my data when I lose 2 nodes out of a cluster, versus if I have 32, I have more chances that I lost a little bit larger chunk of data when I lose 2 nodes in the cluster.
No, because, okay, so if you only have 3 nodes and they each have 256 tokens, you're still spreading those 256 tokens across that entire range. So
Right,
if you're
not for
using
the 3 node example would be perfect, but say like a 6 or a 9 or a 12 node cluster, right? On a 12 node cluster, I lose 2 nodes now. Earlier, I lost this 256 is so randomized that the chance that for a same partition to be available in both of those guys which I lost would be so random, or the probability is so less compared to when I use 32 or 64, right? It just multiplies down by 4 times that you take, right? 32 to 256. So my randomness of losing a single piece of data is more when I reduce the number of vnodes versus have more number of vnodes.
So what you're really talking about, I think, is replication factor. So your replication factor is set to 3, whether your vnodes are at 256 or your vnodes are at 32.
Perfect, right. So now my chance of A lying in, say for example, I take this same example, right? Now A lies with there's only 32 partitions or 32 splits of tokens in each of the nodes that I'm going to have versus 256 splits that I'm having, right? So among the 32, the chances that 2 nodes gets the same split or just one portion, I can pretty much draw it out if we want to, right? All we're saying is, yeah, that portion to be lost, say it's like a piece of pies, 32 pies I have. It's just that I'm saying the same slice of pizza is lost in both the nodes is more when I have less number of vnodes versus if I have more number of vnodes.
I got what you're saying. Okay, so actually, yeah, so this would actually be better. So primary replica will still always be 1, whether you're at 256 or 32.
Correct.
So if the primary replica for Q is 2, the secondary replica will be on node 1,
Right.
and the third replica will be on node 5.
Right.
So whether you have 256 or 56, there is never a point where the second replicas will be on the same node.
That is correct, and I completely agree on it. What I'm trying to say is like, it's just, you're splitting a pizza into 32 pieces or 56 pieces, right? Now I lose 2 nodes in the cluster, and I want to achieve local quorum on it, right?
Okay.
Now, when I had 256 slices in my, in a particular token, it's just that it's so randomly that 256 is distributed or 32 is distributed, but the chances of that slice lying in that 2 nodes is, the probability, it's just math I'm talking about. So the per math, if you keep only 32 pieces in there, the chances that you lose that same portion of data is more when you lose 2 data versus there's a chance of when we have the test 256.
Well, it's really just, I think it's, I get what you're saying, I think. In that the total amount of data is still the same, but the ranges of that data.
But ranges
are
of
different.
data is bigger.
Yeah.
Now I have more chances of losing that bigger chunk, which
Right.
might end up like, I may not be
Yeah.
able to achieve
If
local
you had like
quorum
a
in
force,
that.
or a 256 slice pie, you might lose this piece and this piece and this piece.
Correct.
But if you had a 32,
32
you might just
pi,
use
I might
this one.
choose this big chunk of data. So if I have to ever lose data, my local quorum conditions might start failing if I have lesser number of nodes compared to bigger. But I understand on the contrary, it's like a
and
performance gain.
I don't, yeah, because when you said lose at first too, I was trying to say that was like complete, like it's gone, like there's, versus like it'll replicate and you'll eventually get it back, but you're not
eventually
achieving quorum.
We are not
right?
achieving quorum, so transactions start failing at that point. So the probability of failure is a little bit bigger when you reduce the number of tokens.
It's actually the opposite.
That's great.
Yeah.
That's great, but
I don't know if we
that
should
is
do
correct.
that.
Yeah,
What is the
I think
fees that we use?
but
You
is
still
much
achieve,
smaller.
Is
you
it
won't achieve
than
local quorum with the same total
Okay.
amount of data, but the,
Is it safe to assume though?
whatever
that
data is
if I
next to
say
each other, might,
32,
which, but because those
then
partitions
my
are
range
random
cannot be
anyways.
larger than 32?
Right.
Excuse me, a little bit louder?
So is it safe to assume that if I reduce from 256 vNodes down to 32, then my ring can be no larger than 32 nodes? Because there would be nothing to
That is
add.
correct.
No, that's fine.
So you have
Okay,
random
so pretty much,
It's just like not running anything.
okay, so I'll cover the way that it works first,
6 times.
in older versions of Cassandra, right? You end up having,
No, my.
okay. So if you have a 4-node cluster, and if you end up having just one number of one V node per node, right? This is gonna have, I guess I'll probably work with math. Let's see. We'll have 1, 2, 3, 4, right?
You write the
If I lose this node, I'm taking all of this range. If I were to split it, I would later have, I guess, I'm
Now
trying to,
you're.
yeah, like I'm trying to do like a good graph to like show it. You want it? Yeah, go.
Yeah.
Yes. So at the end of the day,
So you had like 3 copies of this data, right? So one lies here, and 2 lies say here and here, and 3 lies this. This is easy for me to read it that way. So 4 lies here and here, right? Now all I have, my vNodes is still 1, I don't split anything, right?
Okay.
Each node is responsible for only 1 token. It's just the replica factor 3. It's like this guy is pretty much, if I have to call it primary for this node, right? This guy is primary, so it's all responsible for only 1 vNode. vNode is 1 here, right?
yeah.
Now if I lose this guy, it doesn't matter, one is available somewhere else, right? Meaning the more I split it into vNodes, more randomly they are split. The one is not essentially in this 2, say for example, these 2 are in a same rack, right? Like rack 1, and this guy is in same rack like rack 2, right? If I lose these 2 nodes here, I lost my copy of 1, I lost my copy of 1 here. So anybody who are trying to establish a local quorum with 1 will start failing, correct?
Let's not add racks right now, just because racks.
Not racks,
are-
I mean, let's not even talk about racks
Yeah.
at this point, right? These 2 nodes fail at this point, right? I start my transaction starts failing for one, anybody looking for one,
Okay.
correct? This is with vnode just one, vnode equal to one here we try, right? So if they are responsible for, as we go more and more, there is more and more randomness that the way the data gets distributed. Right now, when I lose a node, only I'm losing like this chunk lying next to a neighbor is so granular when the more and more vnodes we introduce and more randomness we introduce, right? So if I had like 32 nodes or just four slices of it versus 8 slices of it, I'm reducing my loss. That my randomness of this chunk being the same, say it's responsible for 1 to 4, and then in here it's responsible for 1 to 4, and me losing these 2 pieces versus once I break it down to 256 pieces, my loss of, meaning my probability of having this range same in the 2 nodes that I'm losing reduces, that's all I'm saying.
But the counter of it is, if you have rack, if the whole thing is rack away, now you're not, if you lose the whole rack, you still have all of the replica, like if your RF equals to 3, then you have all of that data in 2 of other racks.
Correct.
So you are never going to lose the whole pie.
Correct.
Unless.
But that's why I took a rack at the property, right?
Yeah.
Even if I'm rack or not, it's just that the more you split it, the more random you split it, more chances that you lose that same portion of the pie.
So
The thing is,
that it's
sorry.
the higher the vnodes, the worse your availability story is, which is I think opposite of what you're saying.
The worse the availability is,
With 1 token per node,
right?
in order for 2 nodes going down to affect availability, they have to be 2 nodes right next to each other in the ring.
Mm-hmm.
With 256 vnodes and a 5-node cluster, any 2 nodes going down is essentially a guaranteed loss of quorum availability. So you're trading operational complexity with the headache of dealing with tokens for a greater potential loss of availability.
But what I think he's saying is that once you lose those 2 nodes, the amount of data that is affected by the loss of the
Sure.
quorum
Right.
is probably smaller.
Right, but I mean,
when it assigns, I thought at least Murmur 3 partitioner, when it is assigning partitions out, it's just that
Yeah.
that smaller piece to lie in that same piece, the same zone is so many.
Yeah.
For those partitions to be the same way partition on another
Well,
node
I
is
think you
right,
have a bunch
you
of
have
numbers.
a smaller loss of availability, but it
Right.
happens for any 2 nodes going down in the cluster rather
Yeah.
than just 2 nodes that have to be right next to each other, right? So it decreases the amount of data that's unavailable, but it increases the guarantee that data will be unavailable.
I think it's the same Murmur 3 partitioning, 32 or 256, so it shouldn't be doing good on 32.
Right,
it's just
I'm
this.
saying I think you should follow Joaquin's, I don't
Okay.
think 32 or 256 is gonna have a big,
I'm just asking about how
I think
random the data would
it
be
needs
too.
more mathematical analysis, but the way I look at it is like the volume of data that you lose, even though it's smaller chunks, you lose huge number of smaller chunks that may again kind
No,
of.
it just have to be coincidental that that large chunk has to match what the other node had for you to lose a quorum on it. Right, versus if I had 32, I'm just thinking it might be a larger coincidence that these 2 guys have the same.
well, but with 256, unless you have 256 nodes, it's guaranteed that they will overlap.
Correct. Yeah.
So there will be loss.
Mm-hmm.
Yeah, I mean, it will be distributed across the same amount of nodes, so again, you are likely that like the big partitions or bigger vnodes, your smaller vnodes will also get distributed across similar nodes and get stuck in that, you know.
Alright, we should probably
Yeah,
get back to the talk here, we'll talk about this later.
So you were saying to change the number of vnodes on the node, on the cluster, you have to basically set up another cluster, and, okay.
Yeah, so if all of your nodes are already at 256 and you want to increase the streaming throughput and you want to move that to 32, back to that other rule where all nodes need to be equal, you can't go ahead and say, hey, each node's going to have 256, but this one's going to have 32. Instead, it's probably just better to say, hey, this is my 256 cluster or data center, and this is going to be my 32 vNode data center. So you go ahead and bootstrap this new data center up, then you could kill the old one.
Okay.
And then just to get back to your question, like at the end of the day, in this case, you're still losing 1/4 of your pizza. Whether your pizza is distributed in smaller chunks or in larger chunks, it's still 1/4. I think instead of focusing on the vNodes for the issue that you're trying to solve, I would probably focus on the racks. And as long as you have your rack set up correctly, then your original concerns are like kind of dissipate because the racks will definitely like cover you. But at the end of the day, like the only reason for me or for TLP to recommend 32 or 64 vNodes is to lower the operational complexity of streaming operations. Yeah. And I will cover the rack thing at the end of the presentation, and that should help maybe a little bit, hopefully. Yeah. Okay. So, any other questions so far on the Bootstrap process, or on the normal Bootstrap process? Okay. So the other, so the second way to go through add-ons.
Last question. So are you recommending everybody to use a constant range movement equal to false in general or on need basis?
Well, which set of false?
Consistent range movement equal to false.
Oh, no, yeah. So consistent range movement equals to false is only if you're adding, I'm almost positive you could add, or can you add more than one node, sorry, if you have 3 racks, can you add 1 node to each rack without consistent range movement equals false?
If you wait the 2 minutes.
You wait the 2? Okay.
Yeah.
So yeah, so
No, my question is like, last week I lost 3 nodes in one availability zone.
okay.
And I want to quickly bring all 3 nodes. But as I said, like, each node bootstrapping is taking like 1.5 hours. So I need to wait, it takes 6 hours to bring all 3 nodes online. So instead I can go with constant range movement equal to false. But I'm asking, are you recommending as a general practice or only on need basis you are asking us?
No, if you lost 3 nodes at the same time, and they were all in the same rack?
Yeah. We are along in the same availability zone. I mean, there is an issue at AWS end, but we want to survive like if we have same issue in the feature too. Like what happened was like when we set up the cluster in 3 availability zones, so due to insufficient capacity, they only provided in 2 availability zones. And later when the storage is available in the 3rd zone, what they have done is they have terminated the existing instances and they have give us a new instance in the new zone. That means like 3 nodes are down for me in cluster. So I want to quickly bring all 3 online. So if I go with the regular bootstrapping process, it's taking like close to 1.5 hours for each node. So 6 hours for all 3 nodes.
So a question for you before I even like give you the answer is how many racks are you currently using with Cassandra? Is it just 1 rack?
3 racks.
3 racks. Okay. And within the availability zone, we've only lost 3 within 1 Cassandra rack.
Yep. Each availability zone is 1 rack, right? So we lost 1 rack completely.
Okay, cool. Yeah. So if you're doing something like that,
no, that is a quick fix. I know that range movement equal to false, but I mean, do you recommend it use it as a, in general, like standard across all the things, or like on need basis you want to use it?
yeah, for it's definitely as needed. If all the other options won't work for you and you absolutely have to do it, then do it. But other than that, try not to. So what ends up happening is the nodes might not get all the data, so you end up running the risk of like stale data being reported, or possibly even zombie data, because I'm not very familiar with range movement equals false.
I don't think you should.
Not zombie data. Okay, so you shouldn't have zombie data, but either way, it won't be fully consistent. So if you were to lose another 3, then we have the possibility of, hey, like we never had that replicated over here, so there's no guarantee that it's actually work. But since it's all within racks, then you really don't need to care that much because the other racks will be able to support you. Yeah. But at the end of the day, if you do range movement set to false until you run that rolling repair, you have inconsistent nodes, or you have the possibility of having inconsistent nodes. Any other questions? Okay, so So the second way to go ahead and add nodes to the cluster is to use the replace address method. Replace address should only be used if a node is completely dead. So that means you can't SSH into the node, which is a problem that we were having last Friday and the Monday that followed. Also, if maybe you have a corrupt disk, just completely, maybe someone actually fat fingered an RMR star with a scrub or something like that, if it's completely gone, then that's when we say use replace address. We've had some customers that just needed to bootstrap a little bit faster. They figured, hey, I'll just use replace address and throw these other things at it. Like that's not the case at all. Just if it's dead, if it's one node, replace address is what you're looking at. And the way that works is the one node announces saying, hey, I'm going to be that new IP address or hash really. When it comes in, it's going to go ahead and ask for all the data from the secondary replicas and say, hey, like I need that and everything else. And then once that's done, it gets into the up and normal state. TLP generally recommends an odd number replication factor, and the reason for that is if you're doing quorum on 2, quorum is the number, an integer division divided by 2 plus 1. So 2 divided by 2 is 1. Plus 1 is back to 2. So you're always writing to 2 nodes at the same time. If you're on 3 nodes, 3 divided by 2 is 1, plus 2 is 2. So you could write to 2 nodes and then you could read from 2 nodes out of the 3. If you have important data, we do recommend that you write at local quorum. If you want to avoid stale data, then we do recommend that you read at local quorum. If you ever want to be consistent all the way through, then you read at 2, you write at 2. So the reason that's important is if you're doing replace address and if you're only writing at CL1, if you wrote my birth date into like node A and node A just died and node A didn't have the time to send the hints over to the secondary replicas, then you've lost that piece of data. If you were writing at quorum, then at least 2 of the nodes got that right and you could lose node A and you're fine. But also remember that while node A is offline and we're going to go ahead and add that new one, until it's fully online in the up and normal state, not in the up and joining, but it has to be up and normal, the other replicas will have rights that belong to me, but like sometimes network things happen, sometimes a machine will like restart, it just doesn't come back online, and like you kick it, it turns on. So for 3 hours by default, the other nodes will go ahead and keep those hints. So once that node comes on, if it's still in that 3-hour time window, it will receive those hints and it's fully consistent. If it doesn't come on within those 3 hours, you will need to go ahead and do a repair. There are ways for it to kind of like to stay consistent, which is like this read repair chance that only like works on like 10% of data. So at the end of the day, just if you miss that hint period window, you're gonna have to do that repair. I expanded the text a little bit, but it was pretty large. So I covered the high level topics. When you get the PDF, you can read a little more. So for the replace process, the first question, like the pre-rep, is if the node is unrecoverable or inaccessible. If it is, then you can also go and check to see, like maybe you want to go through and replace or rebuild the node using snapshots, but typically snapshots are for disaster cases where US East 1 gets hit with like a hurricane and it completely knocks out like your availability zone, and your snapshots are backed up to S3. Something like that might work if that's like your only data center, but again, like someone fat fingers something. But other than that, like just keep your snapshots for the worst case scenario. You also only have 10 days by default to go ahead and replace that node. So that means as soon as that node died, that's when your clock starts, and you have to add that new node on. It has to finish bootstrapping all the way through, and then we can go ahead and if all that's done within 10 days, you're fine. Anything past that, you might lose tombstones, and you might end up streaming the fact that I had like 5 kids or something as part of my data, and there was a tombstone that said, "Nah, dude, just remove him completely." When it comes back online, if I only got part of that data, everyone else lost their tombstones. The new truth is I have 5. I'm a customer in your database, and I have 5 kids. And if anyone asks, I'm going to tell that, and I will also share that information with everybody else. So in order to prevent zombie data, just make sure you do it within GC grace seconds, which is 10 days. If you can't do it, then you use node tool, a remove token, and that will just go ahead and remove that token completely. Say, hey guys, we've lost something. Let's just move forward now. And if the answer is yes to all those questions, then replace address is good. Any questions on replace address?
Could that be used from getting a bigger node in, or maybe not?
Yeah, that's probably.
Replace it with a bigger node?
Yeah, so rebuild is probably better for that.
Oh,
So replace address is strictly like, it has to be part of that first question, is it unrecoverable or inaccessible? If it's not, then there are probably better
Something
ways.
else.
Yeah. Are you gonna ask?
I want to say that if you do this, you still need to clear out those same directories, right?
Well, replace address would be a completely new IP address,
New box.
replacing the old IP address. Sorry, but it would be a new IP address replacing an old host ID.
I don't think it has to be, does it? Or does it?
A new IP address?
Maybe I'm confused. I'll tell you what, never mind.
Okay, cool. Okay, so the rebuild thing. Okay, so your question was, do we have to clear out the data directories, right?
Yeah. So yeah, it must be.
Yeah.
Okay.
So for this one, like the first prereq is it unrecoverable or inaccessible? If it is, then there are no data directories to replace because you can't even access that node.
Yeah.
So you're not using the same IP address at all?
No, it's a completely new machine.
Well, okay.
And on that new machine, you just had Cassandra installed. There shouldn't be any like any data directories on that.
Rebuild was that was like node tool rebuild.
Oh no, this is the replace address.
No. Yeah, I understand. But the rebuild, is that a YAML setting or is that a node tools?
I think that's what you're covering next, right?
Oh yeah, that's
Yeah.
that's next portion.
Okay. Yeah, because like for instance, if I have a node down, and it's basically I'm stuck because of the disk situation, where I know I have a lot of tombstones, but like I cannot get more disk right now because reasons.
Yeah.
Things that I have done many times before, I want to say, is that I shut it down. I delete all the stuff like you showed up there, and then I set this setting. I set this setting to be the node's own IP, and start it.
Okay, cool.
And then I want to say that was effectively a node tool rebuild, right? Except if I do a node tool rebuild, but the node is okay. Well, I'm just stuck talking.
No, yeah.
So I should just listen.
No, yeah. So that's actually a good case. I didn't even consider that, but yeah. So we'll definitely fall into the unrecoverable, inaccessible because we already ran out of disk, and something's kind of wonky. Although I would be concerned if you're replacing that node with the same node with the same disk capacity, then at the end of the day, you're still going to end up getting that same
right. I'm
amount
just
of disk.
buying time. Yeah.
Exactly. Yeah. Okay. But yeah, and in that case, what we're still doing is we're saying, hey, the old node completely, we're not even going to touch it, and let's just go ahead and pretend this new node is completely fresh, and that's like us pretending it's a new node, and yeah,
Right.
sure, replace address will work there.
Yeah.
Because otherwise the node doesn't even come up with it. And it comes up
Right.
with just complaints that.
Right, and that's the problem.
Yeah, I already know this IP address, I cannot join this IP address again, so the only way to make it work is to just fake it saying that replace address and put the same IP in, just to put it.
Right.
Otherwise, it just doesn't come up when he's trying to start it. If he cleared the data directory like he wanted to, right? So he wiped out the data directory, when it bootstraps, it knows that there is IP already existing in the ring and this guy is already coming up as fresh, so it just doesn't allow unless, it explicitly throws out a warning, I think, saying that use replace address.
Right. Okay. Cool. Yeah, I was kind of worried about that. So you definitely do have to change your IP, right?
No, meaning you then get into your ENVSH and then put the replace address IP as the same address and then bootstrap it.
Oh,
and
okay.
make it work, yeah.
Okay. Cool. Nice.
And I feel like whenever you use this, there should be like a last bullet that says like, be sure that you update your YAML after you boot.
Oh,
Like
so
it
that
says,
way-
say DSC Cassandra or whatever,
Yeah.
then you go edit your YAML. You have to remove it, you know what I mean? Because or else next time.
Is that taking Bootstrap false or?
It's not the, I think intermediate message.
Yeah, it's
Oh,
in the-
okay, yeah, I apologize, I don't know where it is.
Easy or,
Yeah.
I think it's something.
Yeah, it's definitely in the Cassandra emb.sh. So I'll go through and I'll update that because that's a good point. There is a new flag though. It's replace address on first boot. So that means you can kind of leave it laying around as long as there is no data. It will replace address. If there is data, it won't even like use that setting. So
Is
it's
that
a
a
little bit.
310?
Huh?
Is that a 310 feature?
I don't know when it got introduced, but I know it was definitely new. Maybe as 2.2? Yeah, but it's definitely around. Yeah, so if you can, look for that setting. If not, just go ahead and you use a replace address. You boot it up, remove it from your environmental variables file, so when it starts, you're fine. Any more questions on replace address? So the third way to go ahead and add nodes to the cluster is rebuild. Rebuild is definitely best for adding new hardware. So the way that works is you want to go ahead and add new nodes to the cluster. Okay, so in this case, I'm going to assume that we have the network topology strategy, and we're just going to go ahead and say, hey, we're going to replicate key space foo to DCA and DCB. You don't change that, and you don't say, hey, we actually want DCC. You just leave it as is. We go ahead and start all the nodes first. After we're done starting all the nodes, you can go ahead and run a replace address command. And what that's going to do is it's going to stream data from a data center of your choosing. The nice thing about this is you can actually stream data from multiple data centers. So if you end up having the same key space replicated to multiple data centers, you say, hey, I want to replace from over here, so that way you don't crush the read-write latency on this one, and you just kind of like spread that across your data centers. This is a little bit more of a lengthy process. There's 3 or 4 slides on it. The prereq is to always have a network topology, or to have the network topology strategy. If you're using a simple strategy, you can't pull this off by any means. So just make sure if you're on simple strategy, you change it, use network topology strategy instead of replication factor of 3. I'm saying DCA is going to have a replication factor of 3. DCB, you completely leave off. You also want a DC aware policy for your Cassandra nodes, or your Cassandra driver. If not, you can go ahead and contact any one of the nodes in the cluster, and you don't want to do that. You want to have all your nodes only access the data center that actually has that information. You also want to use local quorum or local 1. If you were to use 1, you can send a read request to DCB, and DCB has no idea, like it's barely turned on, it definitely doesn't have that data. Same thing goes with quorum. If you do a normal quorum, you would hit X number of nodes, or like divided by 2 plus 1 across the entire cluster. And we don't want that. We just always, if you're on network topology strategy, use local as a good rule of thumb. So then the next step is to go through and bootstrap those nodes.
Sorry to interrupt.
No, sure.
So while running node to rebuild, where exactly would you provide local quorum setting?
Oh no, these are all just prereqs for, just before you even get into that state. And this is before we even go through and bootstrap any nodes. This is just like, if you only have one data center, or if you have a cluster and you only have one data center, then make sure these 3 are set first.
Sorry to interrupt.
Oh, no, okay. So then, after all those 3 are set, then you can go in and bootstrap the nodes, and those bootstrap nodes won't get any requests. They're completely by themselves, and now you have time to do your thing. So then, once they're all on, that's when you go to modify the network topology strategy, and you say, hey, I want to go ahead and have 3 replicas in DCB, or DCA, and now I'm going to go ahead and also have 3 replicas on DCB. At that time, data starts trickling over by way of hints, but it's definitely not going to just completely come online and like just that bootstrap process that gets that node consistent. That's where you go through and you run that rebuild. And when you run the rebuild, you can go ahead and choose, hey, I want to rebuild like each and every node, you go on node 1, you say, I wanted to rebuild from this data center, node 2, I want to rebuild from this data center, or you can even do node 3 and 4, rebuild from this other one. Once the rebuilds are done, if you want to deprecate the data center, in the case of going through and replacing hardware for something beefier, then you'll want to change your DC aware policy on your application to not contact the old data center, but instead only send requests to the new data center. Then you go through, you change your network topology strategy, and you say, hey, I'm no longer replicating to DCA, only send it to DCB. Once we have that, we could remove those nodes and you kill that, like you just turn them off, stop paying Amazon, and you're fine. If the intent is to add a new data center, then you would want to go through it and add a new set of application servers, and these application servers will also have the DC aware policy, but this time you're going to go ahead and say, hey, I only want these applications servers in US East 1 to contact my cluster in US East 1. Sorry, my data center in US East 1. While the old data center over here has their own application servers, and those are only contacting US West 1. The questions to ask yourself if you want to do a rebuild, it's are you trying to add or deprecate an entire data center? And the reasons for that would be if you're trying to migrate to new hardware, if you're trying to move to the cloud, trying to move back to the cloud, trying to try a different cloud even, this is where rebuild works. So if it's yes to like any of those questions and you want to do it like an entire thing at the same time, or also even change your number of vNodes. Because our old rule was all nodes have to be the same at 256. If you say, hey, now I want to use 3264, you go ahead and you add nodes. All of these are set to 32. These were all set to 256. You bootstrap them in through that rebuild process, and then you can go ahead and toss those old ones, and these are your new nodes that you'll rely on. Also, this is a well-trodden path. So, like the Bootstrap process, this is very nice, very well maintained. As long as you're pointing your application to one data center, you can do whatever you want over here. Things break, start a fire, nothing's contacting that until you say, now it's time to contact. Any questions on the rebuild process?
You had on there not to set a replication factor. When do you add it back in, or?
Yeah, so the first part is to go through and add all the nodes first. And once all the nodes are online and part of that data center, that's when you go through, you say, hey, I actually want this key space replicated here, and then you ask for the rebuild. And then on the rebuild, it pulls in that data. Because if you were to go ahead and say, hey, before we even get to this like stage, if you were to say, hey, I want the replication factor to be 3, 3, and 3, the first thing that you have to do is add one node. When you add the one node to this data center, it now owns 100% of that token range, and it will start accepting 100% of this. So, and because we don't want to do that, we just say, hey, you don't own anything, just turn on, figure out what your tokens are. Once we figure out what your tokens are, then we'll go through and we'll start streaming.
So it won't accept any data without that?
Yeah. Yeah, and that's just to give it the time and not get overloaded and say, I want everything, because the first node wants 100%, and we don't want that yet. Any more questions on rebuild? Cool. Okay, so a few more slides. To check status, whenever you're streaming anything really, you will be writing files. When you write files, these SS tables will want to be compacted. So you can go ahead and check your compaction stats, and if compaction stats are high, that means you're still getting a lot of data. Once compaction stats, drop to 0 or like 1 or 2, it's Cassandra doing its normal thing. But if you have like 10 pending compactions, you're still streaming. If you ever run no tool cleanup because you were low on disk space and now everything's already bootstrapped, now you're running cleanup, that's also compaction. So if you check compaction stats, you'll be able to see when cleanup's about to be finished. We also, if for whatever reason we're running a cleanup and it's a little bit too hectic, you can always set the compaction throughput. This is also a setting in the YAML file. So if you want it to be temporary, set it via JMX, you're fine. If you want it to be persistent across restarts, set in your YAML file. NetStats will go ahead and show you what's streaming from one node to another. So you can go ahead and say, hey, this rebuild process, we're pretty much done streaming from like these 10 nodes, but this one node still has 6 more gigs. Now you know, once that node's done, your node tool status will show up in normal. Node tool status will show you when it's up in normal as opposed to up and waiting. As far as racks, Cassandra, like back in that peer-to-peer spirit, we're balancing our tokens, we're balancing our data load, our CPU, and everything across the board. It also balances the tokens across the racks. You can go ahead and use racks that are different from the replication factor, but you're having to deal with math and like maybe change things, and it's going to be lopsided. And just keep it simple. It's either you use one rack or you're going to use a number of racks equal to your replication factor. So if you end up having replication factor of 3, you have 3 racks, you're guaranteed that one replica will sit on one rack, and the other 2 replicas will sit on each of the other 2 racks. So that way, if US East 1 availability zone A catches fire, you're guaranteed that you're going to have a replica on AZB and AZC. Always make sure that your racks have an equal number of tokens. If not, what you're doing is you're splitting the range on this side across 5, and you're splitting the range over here across one node, which is now owns 100% of the replicas, and in this one you're splitting it across 10, which doesn't make a lot of sense. So just going to keep your racks equal. This has 5, this has 5, and this one has 5. Also, to keep in mind is internode security. So we do have the ability to send information between the nodes or between the data centers with encryption. By default, encryption's off, but if you have 2 data centers and they're both in US East 1, maybe you don't care so much, and you'll have that be unencrypted traffic. Anyone within Amazon, if they're plugged into a network jack, could potentially read your personally, like your PII data. If you're sending it from US East 1 to US West 2, you definitely want to have SSL encryption on that. So that way it's going to package that up, send it over, but within that data center, maybe you don't need that extra encryption, so it's going to lower your CPU usage. But yeah, if you're running on the paranoid security settings, encrypt it from machine to machine, maybe even encrypt on disk, like your call, but just keep in mind, if it's across an open network, you want encryption there. An exposed JMX export. So before Cassandra 2.1.4, we were exposing that publicly, and there was like some news reports saying like, oh, Cassandra got hacked, and there were all these like ports listed off instances that were running in AWS, and it was like, oh, Cassandra like security thing. It's like, no, we just had a bad setting. We went in and changed that setting, so now it binds to localhost. So if you ever need to run JMX commands, like node tool, or actually like do something a little bit more in depth, then you'll want to change that from localhost to the IP address, and then you also want to go ahead and open up your firewall settings. But if you're doing something like that, I'd assume that you're already like looking at security stuff, and just make sure you're not opening up to the world and just to a specific IP address. And that IP address isn't changing, you're the one that has access. So for removing nodes, there are 3 ways to remove nodes. First way is to decommission. Decommission should only be done if the node is up and healthy. So that means like, hey, I had a 10 node cluster. I actually don't use like all that like much CPU. The disk load per machine is actually fairly low. I want to consolidate that. Go ahead and use a decommission. What decommission does is says, hey guys, I'm leaving. Figure out your new tokens, and I'm going to stream my data back to you. And once that's done, I'm out. After 72 hours, Gossip starts echoing that I was even part of the cluster. If that node is completely dead, then you want to use remove token. What remove token says is, hey guys, that guy's out. We have to figure out who's going to own its new tokens. You all got its new tokens. Have a good day. So that means now you have to run a rolling repair to make sure that that node, that each node gets the data that it should be getting. The last way to remove a node, and this is not a hammer, is to use assassinate. Assassinate used to be a JMX command where you actually had to use like JMX mbeans to go inside and execute the unsafe assassinate thing with an IP address. And I kept asking opponents in support. I was like, hey guys, like we need to make that accessible. They're like, no, you don't need to do that. So finally, after like years, it's now accessible through node tool. What that does is it says, hey guys, forget about that node. It never changes anything about token assignments or who's gonna like be the next owner. So if you ever run assassinate and you didn't either do a decommission or remove node that actually do that token like reshuffling of sorts, then it's just going to remove it from gossip entirely, and now your cluster's in a wonky state. I actually don't know what that looks like, but just don't do it. So yeah, like I tell people this because it's like really cool. Like I love it because it stops those echoes, and it's mainly a cosmetic thing. If you follow the correct processes, you did your decommission, you did your remove token, but this gossip thing keeps showing up in the gossip state, and you're running your metrics, and now it's in your metrics, and you want your dashboard to look pretty, then go ahead and do that. At Umbel, we had a 42 node cluster, and for some reason, like one node stayed around for like 2 weeks, and it was cosmetic, and we hopped on low CPU usage and everything, and we executed an assassinate. It stayed there. Like it removed itself from my gossip info, but someone else had that same IP address, so it replicated over here, and now it's here again. So then we ran it 3 times, and like it's like, okay, cool, it's gone, but someone echoed it back, so now it's here. So what we did was we PSSH'd into all 42 machines, and then we ran it 3-4 times, and then finally like all of them said, I'm clearing my gossip info. No one had that gossip state, so it stopped getting echoed. So just heads up, it's cosmetic. You can do it multiple times, but again, it's not a hammer. So yeah, so to recap really quickly, we covered peer-to-peer networks. Casa was not really peer-to-peer. BitTorrent had a nicer peer-to-peer. Cassandra is more of a stateful peer-to-peer, it's all under your control, so we have gossip like helping things out. Fundamentals, you're dealing with token ranges. With vnodes, you're dealing with multiple token ranges per node, which helps the Bootstrap process, so you don't have to actually move token ranges around. You have more randomization, higher randomness to it. Seed nodes are used to enter the cluster. They are also used to keep a more up-to-date state, but other than that, seed nodes are not special. But if your seed nodes are down, you cannot add nodes to the cluster. Adding capacity, you'll want to either do Bootstrap if your nodes are healthy, only use replace address if your node is dead or inaccessible, or you can hack it and stuff, but again, like it's the fact that we've lost something. And then rebuild is if you ever want to change like a major setting like vnodes or replace hardware. Excuse me. In order to look at status, you'll want to look at byproducts really, which are compaction stats, the amount of streaming that's happening from node to node, and gossip entries. And gossip entries, there's gossip info if you really care to see like what it looks like, or just use node tool status, and that will tell you it's up and normal or up and tweeting. And yeah, just be mindful that we want to keep our racks balanced. We also want internode encryption if we're doing this across a public network. And we also want to make sure that JMX just isn't exposed to just normal like security firewall things. And to remove nodes, we want to run decommission if it's a live node, and we want to say, hey, I'm leaving the cluster, have my stuff, have a good day. Remove node if this guy's down, and we need to take care of this, or reshuffle everyone, like repair yourselves, I'm not going to handle that. And then assassinate only if it's a cosmetic issue, because we already followed the above 2 steps, but someone's echoing something. Yeah, so any questions? Comments, concerns? Oh yeah, so my email address is here. If you all have questions, feel free to reach out.
Thanks, Joaquin. Anybody need a parking validation ticket? 1, 2, 3. Anyone?
No, I got it. Yeah, the first thing I get.
So Joaquin, before you add that second node, can you add the second node while it's in UJ, or you want to wait till it's UN? It's up and normal before adding the second node.
If we're bootstrapping, all the nodes are up, and we want to add 2 at the same time.
Well, so when you add the first one, and it heads into UJ,
And like this is the very first node in a cluster.
No, say 5-node cluster, you're adding a 6, well, you need to add 2.
Okay.
So you add the
Same
6,
data.
I'm sorry?
In the same data set?
Yeah. So when you do your node 2 status, you see it in up join. Now, do you need to wait till it goes to up and normal before you have the second? Or you want to do that, right? Next. Okay.
Yes, so if you do it that way, because nothing joining is it's not really committed. It's, you know,
Okay.
if it disappears, it disappears, so token ranges aren't really set yet.
Okay.
Once it's in the abnormal, we're gonna say, hey guys, these are these token ranges, so the second node that comes in will take the proper token ranges.
Okay.
If you do two of them side by side, then you'll need to range inconsistent thing, or flag, and that says, hey, we're just gonna pull as much as we can, we're gonna make it work. But then after that, it's up to you, because you wrote like a sort of contract, now it's up to you to make sure that they're all repaired.
Yeah, we have 5 nodes with about 800 gigs each, so we'll be adding 2 nodes. I'm not sure how long it would take to go finish on one node.
Well, it's 800 gigs each.
Yes,
I mean,
SSD, it's only gig network though.
okay, yeah, so, I'm really badly about specs, but I mean, I know
And
that.
this is not cloud.
Oh, not that, not cloud. That might be a little bit, yeah, so it might take a little while, what you're saying, like 6 hours or something?
I don't know. Yeah, well, that's our, we may not be able to do both. We have 6 hours, we may not be able to do both.
Okay, so you're constrained by like a deployment window or something?
Yeah, well, we have a maintenance.
Okay, in that case, I would just say schedule one on one day and the other on the other, so that way you don't have to rush yourself, but also you make sure consistency's high.
Right, so it may require 2. Okay.
But at the very least, like really, as long as you start it, like your maintenance window is like really 10 minutes. Like you start it, it does its thing. If it fails, you don't have to play with it.
But we can't start the other one till it's in the normal state, up and normal.
Unless you're okay with reading and writing for them, so that way we go ahead.
We
and
already
run
have
this.
that, yeah.
Oh, you do?
Yeah, we already read right quorum.
Okay, well, if you're reading, writing quorum, then sure, go ahead and add 2. You want 2 minutes to have a gossip state be standard,
Okay.
and then you want like an additional 3, just, special practice,
Okay.
because your 2 minutes might be off from Cassandra's 2 minutes. So wait for 5 minutes, then you can start adding the next one.
But the safest would probably be
One.
wait on the none. Okay. We'll go the safest route.
But if you need to rush it, then rolling repair would get you back to what you would have.
Okay, yeah, take a while.
So you do range?
Yeah, exactly.
So that is with range movement equals to false, the 2 nodes adding is with range movement equals to false, or just 2-minute gap is sufficient?
So if you're doing it in different racks, and you only have 1 rack, right?
Yes.
Okay, cool, yeah, so if you're doing it across 3 racks, like, let's say, you can go ahead and add 1, wait 2 minutes, plus additional 3 for safety. Then you can add 1, 2 minutes, 3 for safety, and you got the other 2 minutes, 3 for safety. But if you're gonna go ahead and do it just in 1 rack, then you go ahead and you'll go ahead and add 1, and you will need to go ahead and say the range consistent movement. Are you writing it for them?
Yeah.
Okay, cool. So if you're doing quorum, that's a little bit safer, but it means at the end of that process, you may want to run roll.
Right. Okay, so just add it without range movement equals to false, but just do a repair after.
No, add it.
With the, with equals to false. Okay, makes sense. So,
Just in general, like, just for the basics, mem tables are sorted, right?
Mem tables are what?
Anything in the mem tables is sorted. And any entry that goes into the mem table is sorted.
I don't think they're sorted, they're hashed.
SS?
Yeah, SS.
Oh, SS tables on disk.
SS tables on disk is sorted, but mem tables is already sorted so that they just go in line with this.
I think
Web
they're
tables
hashed.
is just direct hash access, there's no.
Yeah.
There's no sorting, because I think DataStax document says it's sorted. I was just like trying to imagine how does that sort happens if mem table has to be sorted. So it was very difficult for me to imagine that it's going in sorted phase, so.
Yeah, no, because like in memory, like it's super fast. So and there's very few times that you want to even like scan a list of tokens really. So in memory, it would definitely be hashed.
And if you're doing a range scan, you're going to disk anyway, so your the memory's not gonna be your bottleneck.
Correct. No, it was just a evaluation of how the sorting works in the memory when it tries to, when you're following the data and stuff.
Yeah, I think it just sorts once it's writing it out, doesn't
And one question was, if we had to do 1 million writes per second, how many nodes would that take?
Oh, that's definitely dependent on the CPU, and the CPU on the cloud is gonna be different. You're looking at your disk, if you're using EBS, provision, IOPS, how large
I
the disk are.
moved from EBS to say i3s, which is like local volumes, to like.
Yes, so DataStax,
So
would actually
like,
that question try to be
yeah.
but yeah, like we never answer.
Okay.
And like, what is good to do though is if you run a test, or actually, so right now, you're probably live in production, right? And your throughput is, it caps out, or, like, your throughput doesn't really cap out, it's just you'll start throwing stuff and then you start getting like
Drop
drop messages and
mutations,
stuff
that's
like
what we
that.
were saying, and then.
So you kind of figure out what you're running
Okay.
at and how many nodes you're at, and you just do
A math and
linear
then-
scale out. And like now you want 10, or 2 times more, add 2 times nodes.
So pretty much we are doing like a catch up, like we add up 6 nodes, okay, 12 will work, no,
Yeah.
18 will work, okay.
Yeah, there's this, I think if you go to datastax.com/1-million-writes, it's a Netflix,
Netflix, well,
like-
and
yeah,
because
exactly.
I really talking about Netflix and how they scale action.
Yeah, so that was typically like my answer every time people ask me, like, dude, I really can't tell you, but like, it scales, I promise.
But the problem is pretty old, probably I should finish up ours and then refresh ours of how we scale.
Oh, yeah, that'd be good. And then, I think Nick said that there's no talk, in July and August, so.
Yeah. Find out how many nodes it takes and then do a talk.
There you go.
Alright.
Yeah, I give Patch a big day where they were, I went to this talk and it was, gonna be interesting, it was on, Cassandra on the ARM.
Oh, wow.
Oh, yeah, and this was in
Miami?
Miami? Oh, okay, cool, yes, so one of the TLD, people were there and they were really excited about it.
Oh, yeah.
And then they were like, oh, there was nothing here.
Well, I like the talk that guy gave on,
Alex?
Cassandra Reaper.
Oh, yeah, Alex,
Yeah,
yeah.
you need to look at that.
That's pretty good.
They don't have much memory, ARMs.
Well, this,
No,
I was
they-
thinking the
they-
same thing, the little itty bitties. These are it's like, these massive ones where they stick, several hundred of them in and they cost
Oh.
$5,000 or $6,000 a
They
piece.
usually have like at least like 6 gigs, that's how the,
It's not.
Yeah, it's like, man, that's not an ARM, a Raspberry
100
Pi is
times
an
100,
ARM.
right?
Yeah,
Times 100.
yeah,
So I understand all those labels except for one, the bottom one.
DiGiorno? Oh,
Pizza.
That's my question of the night.
Did you watch, have you watched Master of None?
I guess not.
On Netflix? No?
Yeah.
Yeah, okay, so I just finished season 2 like last night.
Oh.
And I realized that the tall big guy, every time like he says hi to anyone, it's like DiGiorno. He's like, what? That doesn't even make any sense. So I was like, oh yeah, bye, DiGiorno. Like that's it.
Okay.
I didn't think I noticed that. I saw that.
Yeah, no, yeah, and I got it on like episode 10, and then I told Tyra on episode like 12, and was like, hey, like, hey, check it out, that's what he's saying, and then we caught it, like, yeah, that's what he says.
Subtitles.
Oh, well, I'll just remember that now. Oh, yeah, just random,
That's awesome.
Thanks for your talk.
Sure. Thanks a lot.
And I'm definitely glad that you saw it. I tossed it in. I'm like, I wonder if anyone was going to see it. So someone did. I carefully studied these labels.
Thank you.
So there's no place there.
I'll see you guys next month.
Go. See ya. Have a good one.
Is that the new one, the Batman? Yeah, that's the new one.
Oh, the Lego
Yeah.
movie? Yeah.
Batman Lego.
Power Rangers is out. I didn't know about that. Not that I'm excited. Man. Oh, nice.
All right, so you don't have to speed home.
Yeah.
You take your time. All right, you guys have a good evening.
So, how are you doing? And do you have any other questions, or are you?
No.
Take your time, sorry.
Good, good talk, man. It's the most audience participation I've seen in a while, it's good.
Yeah, exactly. I was like, okay, cool. And I guess it was useful to like cover the basics. I was like, oh, I got this. But
Yeah, no, definitely used for some,
Oh.
something to grab.
yeah, exactly. I was gonna ask them if they would want the Docker token stuff. I completely forgot. You know, especially since you said like over mailing list it wouldn't work.
I think-
was like, maybe here.
Yeah, I mean, if you wanted to do that at some point, I think it'll definitely go over well. I'd be personally interested in it, so.
Okay, cool. And I guess when's your deadline for realizing that we don't have a speaker? And then how much leeway does that give me to socialization?
I mean, if I can, I try and plan like up to a month in advance. I don't have anybody lined up for July, so if it gets to be a week out and we don't have anybody, either I'll give a talk or I'll just do like a Q&A session for them. So, I mean, do you want to do it in July?
Yeah, I definitely do that. So I'm gonna be out in August, and.
Well, hopefully we're going to be on speaker for August, we'll see.
Oh, yeah, that's right.
But yeah, I mean, if you want to do it in July, put it on your schedule if you want to do 2 months in a row.
Yeah, sure, I do down. Yeah, just, do you wanna ping me, with like 3 weeks of heads up, so that way I can go ahead and have like 1 week just to get everyone like, or my schedule fixed, and then I can do 1 week to do it.
Cool, yeah.
Thanks, dude.
Alright. Sounds good.
Oh yeah, so, any questions on your end, or are we good?
I think, yeah, I don't know if there's like a intelligent or programmatic way to understand, you mentioned like the notable net sets, but you know, like, I'm just thinking from an automation perspective, i.e. like Kubernetes or something, or just like general monitoring, custom monitoring stuff. Like, how do I know when it's really, when I'm good? You know what I mean? I've had bad luck with, I mentioned, I think last time we were downstairs, like, we've had mixed results with the node-tool status in general. It's like, oh yeah, it's normal, it's great, and then, but it's like, no. And then I checked that parameter that you mentioned, there's some, like, I don't know, it's like PHP or, I don't know, some letters.
Oh, the 500 threshold.
Yeah, that thing, yeah, yes, that thing, and it was set to some value that, yeah, I think 8, I think that's the default maybe.
Yeah. And you push up to 12?
Well, it was on-prem, and I have like sub-milli ping times within the cluster. So, based on what I read, it sounded like that's where we wanted it.
Is your CPU or network kind of like hitting capacity? Because if it's doing that, so what 500 threshold does is it fixes blocking node issues, and it seems like that's what you have, right? It says it's up, but it doesn't really act that way.
Right.
Right, it says it's like up, down, and up, down, right? Or,
Well, it's more like I shut it down, and then I go talk to all the nodes, and I do nodeful status, and they're like, yeah, it's up.
okay.
But it's not though. And it will be that way for like 10 minutes or more. I think one time I saw like half an hour. But
In that case, 500 threshold is set too high.
okay, right.
Yeah, because okay, so,
Right. Yeah, you're saying 12 if I was in the cloud or something, right?
yeah, so pretty much if it's blocking, if it doesn't understand if it's up or down, or if its neighbor is up or down, that's when you want to go ahead and increase it, so that way it
Right.
gets rid of the noise.
Yep.
But if you kill it and everyone else says, hey, it's still up, then that means it might be too high, yeah, it's lowered.
If it's set to 8 and you see nodes staying on for 30 minutes, I don't think that's a fucking config problem. That's, there's something else wrong.
Funky. Yeah. Anyway, so we've had I don't know if that's still happening, because like honestly, I don't really do the maintenance, right? Like we'll schedule things in our offshore team, they actually, throw the switch. So I don't know what they see anymore, but that's what I know I seen. And then the other thing was, you know, like when we do, when we were for like about 6 months, we're having very serious issues with basically the capacity. We have so many tombstones, man, it's just ridiculous. And a lot of it was like, we had Op Center, like they tell you don't do it, but that's all we had funding for. So had Op Center running, or storing to the same place that it was monitoring, okay? And oh, by the way, replication factor 5, because these people that, yeah, everything, the whole everything. It's just stupid people who are in very high positions of power and authority. Anyway, it doesn't matter. The point is, because of that, we were having these situations where I think there's even like a defect out there where Cassandra will sometimes, it doesn't really clear out tombstones maybe. But anyway, we kept filling up, like, you know, we had like 4 terabytes of storage, but we're only storing like, you know, we're really only storing about 10 to 20 gigs of actual real business data. But just tombstones, because it's like a session table, which is arguably not the best use case maybe, but you know what I mean? So
You probably want to be using time window compaction strategy.
but
Are you using level compaction strategy?
but I'm on 486, so I don't have that available to me.
So yeah, I don't know.
But with the session though, I was actually kind of worried about session.
602.1.
No, yeah, but we're talking about compaction strategy. Jeff Jirsa has a branch out there, and you just go ahead and build that yard, toss it in with your stuff, and now you got time with the compaction strategy.
Okay.
Like, we do that with quite a few people.
Well, the thing though, is I was thinking about it more, and I was like, but if I have one session though, if I have one session that's like, that guy stays logged on for like an hour, then potentially, don't I wind up having all that junk
Do
waiting
your
out there?
sessions have, you know, a static timeout beyond just the activity timeout?
Well, they do, but it's like renewable, right? So every time you hit the page, right, we give you another 20 minutes, 20 minutes, 20 minutes. So somebody's like clicking around out there for ages, i.e. like one of our customer service reps who's logged on for hours at a time. And then, and they have longer sessions. Their sessions go like long. I mean, they'll have long sessions.
Like 12 hours or 24? Or
Yeah, yeah, you know, I don't really know. We have, I don't even know, 10,000 apps, 20,000 apps, I don't know, thousands of apps, every tons and tons of wars and years out there. But, so anyway, I'm thinking like, I got 13 million members that are hitting it always, and so that all these short sessions, but then there's these big, long sessions, and so I was kind of worried like, if one of those has to stick around, and then we end up having to keep all these files to support that, that could be bad.
Yeah, I mean, time window only works if you know that you can delete data older than some time.
Right.
So you, in that case, I mean, I don't know how much control you have over the application, but a better application design might be like,
Right.
refresh the session by inserting a new session row rather than keeping the old row around indefinitely, right, or something like that.
Okay. Yeah. Yeah, I don't know, and all that stuff like plays games in my mind anyways. So I'm like, okay, so I'm gonna like upsert, so like, does that mean the old one, all that could go away? Or does it still need to be there because it's still the same row over here? I don't know, that's things in my head. Oh, anyway.
Yeah, like worst case, like if you follow the mix advice and then you just daisy chain, like you really need that extra data, and you say, hey, my last session was this. So when you do your reads, you do multiple reads, like worst possible case.
Yeah.
But do most of your customers have short sessions? And if so, then like what Nick said, would probably be good.
Yeah, I think most of them would be not too long, you know.
And now you clear out 90% of your stuff for
Right.
that one client or customer service person. Then you
Yeah, I mean, potentially we could do like minutely or something, I don't know. I don't know what's the finest granularity we could have, if we like really tight, you know.
Yeah, I don't, there is some small stuff like that in here, but I don't remember what it is. It might be, it's either minutes or hours, I think.
Alright.
I'll-
But,
I'll-
Oh, one thing I was gonna say, like with that clean, I think you actually need quite a bit of space or something, at least with the Cassandra 2, because on there I think it tells you like, oh, you need like at least twice as much free space as your largest SS table, and I'm like, that's logical, so I can copy it or something, but yeah, I just know like when I try to do a clean after I reduce the replication factor, so I changed the R from 5 to 3 on op center only, because I just got tired of dealing with it. So it's kind of like a little bit sub rosa that I didn't want to tell anybody. So then I did a clean. I thought it was so smart. I'm like, I'm gonna flip all this space. It's gonna be awesome. Get rid of all my issues. And then sure enough, like I filled up the whole disk because I have concurrent compactions set to 4.
Okay, well, because now that means you want 8 times as much free disk space.
Yeah, and then I guess I probably had SS tables out there that were like 20 gigs or something, and so it's just like, there you go. That did it. So anyway, yeah, that's like a thing. Yeah.
That's definitely gotcha.
Hey,
Yeah.
concurrent compaction, is that okay? Multi-threaded compaction is bad, concurrent is okay.
That got rid of concurrent compaction is fine.
Okay.
But it defaults to 1, so.
Okay. Cool, we'll take care, and in terms of.
You too.
I got you.
up, Cassandra? It's alright. That was the event. Pretty cool. It's good. Have a good night. Thanks, Josette.